Good morning to all. I'm Giulia Leghissa from the editorial board of the Build Up portal. For the ones who are attending a Build Up webinar for the first time, welcome. For our returning audience, thank you for renovating your interest. It is a pleasure to host today's webinar entitled RELaTED Project, Integration of Industrial Waste Heat in District Heating. I would like to invite you all to contribute and participate in this webinar. You can ask questions by typing in the box on the right side of the screen. They will be answered at the end after the presentations. You can also contribute to Build Up portal. Build Up is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents one of the key sources of information on the topic of energy efficiency. You can register and become a member of the community. You can also upload news, events, present a case study, results from a project, and so on. I would like to invite you all to navigate the portal. In the Learn section, you will find all the podcasts of the past webinars, so it is possible to listen to all the previous presentations. In today's webinar, Johan Carlsson, Scientific Officer at the European Commission, JRC, will explore the role of waste heat in the heating and cooling strategy, how it is treated in directives, and some examples. Then Bartolomiej Pawluk, Communications Director for Veolia Energia Poznan SA, will talk about the benefits of industrial waste heat. To what extent does the industrial reject heat help achieving district heating performance improvements? Then John O'Shea, Energy System Analyst at CODMA, Dublin's energy agency, will talk about cluster of challenges, technical and non-technical subjects connected to energy planning for industrial waste heat sources. Finally, you will watch a video about the identification of industrial waste heat sources suitable for heat recovery by Jesus Maria Casado, Renewable Energy Technician, the energy agency of the Basque Country. Now I would like to leave the floor to Johan Carlsson. So please, Johan, we can start the session.
Okay, thank you very much. Hello, everybody. So Laura, can you please open slide 3? Yeah, I cannot see the slide, so I just hope that the third slide is open. So that's the one about the introduction. This presentation then will focus on the waste heat in the heating and cooling strategy, and also how waste heat is treated in the energy efficiency and the renewable energy directives. Next slide, please. So the European Heating and Cooling Strategy was published in 2016. It has as objectives to make the heating and cooling sector smarter, more efficient and sustainable, and reduce emission, etc. Some of the elements that it treats are listed on this slide. It's, for example, make renovating of buildings easier, because as it is now, the buildings are not renovated fast enough. There is a refurbishment rate of about 1%. One also wants to replace old equipment, because many of the boilers, for example, are old and quite inefficient. One wants to increase the share of renewables, because it's not widely used in the sector right now. For example, natural gas is the largest primary energy source for heating and cooling at about 46%, and then followed by coal and biomass. It also wants to reduce more energy waste from industry, and that is what I will talk more about on the following slides. And it wants to involve consumers more. Next slide, please. So when it comes to the waste heat from industry, yeah, we all know that quite a lot of waste energy is dissipated unused in air and water. And then the possible solutions then, how you can take care of this waste heat is, for example, to collect it and directly feed it to a district heating system, or you can use the waste heat to send it to absorption chillers and then transform the heat into cold. There is a lot of waste heat available, and that for some studies say that there are like 20 to 50% of industrial energy consumption that is discharged as heat. So there is a lot of potential. There are several examples of how this is done already, but it could be done much more systematically in more countries and so on. For example, there is an example in Gothenburg. There are areas that are heated with district heating using waste heat from nearby industrial plants like refineries and chemical plants, waste incineration and cogeneration. Example of a cooling system, a district cooling system exists in, for example, Vienna, and there they use heat produced by CHP and then use absorption chillers. There are also many other sectors that could be looked into, like the iron and steel, glass, cement and lime. These are all high temperature waste heat. Chemical plants can also have a lot of waste heat. There it can be both medium and high temperature. Textile can have quite a large range of different waste heat. If you look at beyond the industrial sectors, there are also waste heat sources available, like, for example, IT server halls or commercial centers that one could use. If we then move on to the different directives. By the way, I forgot to say the next slide, Laura. So it's slide 7, the directives on energy efficiency directives I'm at now. In the Energy Efficiency Directive, there is the Article 14, and that is about assessing the energy efficiency potential in the heating and cooling sector. It is big work that member states have to implement. They did assessments on the national level where they could identify potential for improved efficiency. And they did this by first identifying the heat demand and the available heat sources. They also, in most cases, prepared maps so that they would be able then to link heat sources with the heat demand. And they looked into many different technologies like cogeneration, heat pumps, but also other renewable sources. Waste heat was also included, and they were asked to include industrial installations with thermal input exceeding 20 megawatts. This assessment was done in 2015, and now there is a next assessment due by the end of 2020. There are some changes, and that is that they should look more into renewable sources and also into waste heat. Next slide, please. So this slide is about the Renewable Energy Directive, and actually there is a link now between the Renewable Energy Directive and the Energy Efficiency Directive. So the Article 14 that I just mentioned on the previous slide, the Renewable Energy Directive requires member states also to look into the renewable sources. And it's also worth noting that in the updated version of the Renewable Energy Directive, member states should add 1.3% of renewable heating and cooling to the total heating and cooling in the period 2020 to 2030 annually. In district heating systems, they are supposed to add about 1% of renewable sources. And how does this link with the waste heat then, you might wonder? And that is that waste heat can be counted to this target on renewable heating and cooling, up to 40% of the average annual increase. One thing to keep in mind is that the internal processes, if you look at the industrial plant, one first has to look into the internal processes, how these could be optimized before you consider the option to send waste heat to a district heating network. So, yeah, first you have to look at that your industrial facility is working as efficient as possible before you send waste heat. Next slide, please. So, yeah, you might wonder then, yeah, there are quite many provisions why or that support waste heat in the directive. So you might wonder why it is not done more, and that is that there are a couple of barriers that makes it difficult, and I just mentioned a few examples on this slide. One of them are structural, for example, that there are long distances between the source and demand. And another one could be that there is a temporal mismatch. So when the heat is produced at the industrial facility and when it's needed then at the demand. Another barrier is the financial cost. There's a large upfront investment needed to make this happen, and that could be discouraging in some cases. Also, if you make the investment, you want to be quite sure that there is a long-term commitment so that you can sell heat for a long time to your customer. Another thing is that for industries, then waste heat is not the core business, so they might not see it as so interesting as the first option. So thank you very much. I think that was what I wanted to say now about the directives and the heating and cooling strategy. I would be, of course, willing to answer any questions that you might have later. Thank you.
Hello, everyone.
Yes, hello.
So we can share with you an existing example of heat recovery from air compressors. Start at the Volkswagen foundry here in Poznan. It's a quite unique project for us in Eastern Europe, and the first one we made in our CE zone, Poland. The first step of, let's hope, next projects such as this one. Next slide, please. No? May I have next slide? Okay. So the solution is quite simple. Few words commented before. Veolia is responsible for district heating network here in Poznan. We own this district heating network. We are producing heat cogeneration process and using coal as main fuel, of course, 50% share of biomass. And Volkswagen is our long-term customer for system heat. And Volkswagen decided a few years ago he go more into green option, and they asked us what we can do together to change a bit way of consumption of the heat and maybe part of fuel mix. And after the discussion, we decided that we can try some waste heat recovery, because the foundry is producing extreme amounts of waste heat, and at this time we used just regularly cooling of the installation, and all the heat was pumped into the air. So the whole process started with the replacement of the factory compressors with the new ones. We keep with a heat recovery system, and the next steps were on the Veolia side to design and to build a dedicated substation to collect waste heat and to distribute it on this industrial area, and further to the district heating network to the customers of the district heating network. Can I have the next slide, please? So this is a scheme. How is it working? You can see on the top, it's the industrial side, it's the Volkswagen foundry, and the other industrial producer, HST, producing cars, car engines, and also wagons for railways. And you can see that we have one way of during the winter time, which is the blue one, and another one, the green one for the summertime. So during the winter time, all the waste heat collected on the left, where are the compressors, is used for the industrial side, and in the summertime we can collect this waste heat in the substations and put it into the city, like hospitals. It's a nice project because it let us save some energy and also CO2 emissions. And for the Volkswagen, there are nice savings of water they use to cool down the coolers, the compressors. Next slide, please. Well, the whole project took us almost 3 years. The main part was to design and efficient substations. On the side of Volkswagen, there was supply of recovery modules, compressors. They also bought 2 substations and built some of the network. We provided the substation to cooperate with heating networks to provide the heat to the city, and also part of the network. So there's a common investment, and also common project, very important for us, important for Volkswagen. The next slide, please. The benefits, of course, for Volkswagen, the reduction of CO2 emission, of the carbon impact, which is very important because of the new Think Blue policy in Volkswagen. Of course, water savings, as I mentioned before, 70 million liters per year. And also some cash savings, because the water use, and effective use of waste heat. For us, establishing long-lasting customer relations, of course, quite innovative project for us, which is the potential to replicate it with other customers. For now, we are trying to extend this waste heat recovery for Volkswagen, because apart from the part of compressors, they still have a lot of waste heat from the process part, and we are now designing a new solution to take more of the waste heat from them. Simply as it is. So So if you have any question, I would like to answer
Good morning. My name is John O'Shea. I'm the Energy Systems Analyst with CODEMA, which is Dublin's energy agency. And I'm going to be talking about the challenges when planning and developing industrial waste heat district heating systems. So I don't think I have control there, do I? Okay, there we go. Okay, so I'm basically going to just touch on some of the background for the HeatNet project and give a bit of national context as it relates to Ireland. I'll also be touching on the challenges for both the kind of district heating side and the industrial waste heat side. And then I'll just touch a small bit on basically what was the focus of this project, which was our pilot project in Tala in South Dublin. So in terms of Ireland, then I guess the main driver is the fact that heat accounts for almost 40% of the total demand in Ireland, and that when it comes to our renewable energy targets, heating is far behind electricity and transport in that respect. And in terms of Northwest Europe, then I guess we're basically looking at district heating as a method to increase the penetration of low carbon and renewable heat. As kind of evidenced by this graph here, you can see that all the countries with the higher share of renewable heat also have a high proportion of district heating. And as regards the countries involved in the HeatNet project, we're down the other end and have a very small penetration of district heating. So there's sort of a recognition that district heating is a very good way for us to push this renewable heat target up. And to do this, then we're looking at fourth generation district heating, which is essentially a lower temperature district heating network. So it'll increase the sources that are available, so we can utilize lower grade heat sources and use those to provide space heating and hot water to buildings via the heat network. So I guess the other benefit that this allows us is that it allows us to generate an integrated heat and electricity market. So we can use the heat network to balance the grid in a form of demand side response, and we can reduce the amount of curtailment on renewable energy such as wind, which we have a lot of in Ireland. And we can do this kind of cost effectively using large-scale thermal storage effectively as a thermal battery at a fraction of the cost of an electric battery. So this is kind of a representation of what such a system might look like for Dublin. So we have our data center with a heat pump, so it's providing cooling to the data center, heat to the network. We have industrial sites taking heat from process waste heat or flue gas. So we've all these things working together to give us an integrated system. So in terms of the benefits of district heating itself, then they're not just related to heat. I suppose the point that's most critical for this talk is the capacity to increase industrial efficiency. So essentially, using the waste heat from cooling systems and using that to heat a district heating network, and then a byproduct of that is providing cooling to the site. And then when it comes to the planning, then we kind of touch on three main areas. So the heat demand, heat supply, and the kind of constraints, be they physical, scheduling, or political. So the first thing then is to look at the heat sources. So this is kind of work that was carried out as part of the South Dublin Transition Roadmap. And it's basically all about developing an evidence base to make kind of informed policy and to inform policy and business cases going forward. So the heat sources that we'll be looking at today will be the flue gas heat recovery, the process heat recovery, and the commercial and industrial cooling with heat offtake. Next slide. So yeah, as part of this study, then we identified a whole host of heat sources around Dublin. In fact, there's enough waste heat identified to heat 2,000 or 250,000 homes. And this heat demand doesn't include heat from electrical generation or CHP, in which case there'd be an extra 600,000 homes that could be heated. So this is kind of using data which was available from the Valuations Office and the Environmental Protection Agency. But it's kind of worth noting that there is likely to be some gaps, especially in the non-ETS heat sources. And we're sort of engaging with the Sustainable Energy Authority of Ireland in trying to fill that gap as much as we can. But as you can see, there's a lot of clusters of data centers. So there's a lot of data centers in Dublin. There's around 65 data centers, either built or in planning at the moment. And then so we have our heat sources then. So the next thing to look at is our heat demand. So this is just a snapshot from the heat atlas for Ireland, which was developed by Heat Roadmaps Europe. We also have a further map available for Dublin, which was developed by Codema, which is kind of drills down into a bit more detail into where the heat demands are in Dublin. So that was the spatial energy demand analysis done by Codema. And I guess one of the figures that jumped out of the Heat Roadmaps Europe work is that 57% of heat demand in Ireland is at a high enough heat density to adopt district heating. And I guess the third thing then to look at are the physical barriers. So looking at things like infrastructure, roads, rivers, rail, heritage sites, and habitat and conservation areas. Areas that you want to try and avoid as much as possible when laying pipes in the ground. In terms of the current situation in Ireland, then like district heating is very early stages in Ireland. It currently accounts for less than 0.8% of the total heat demand. And at the moment, industrial waste heat accounts for 0% of that. So there's a lot of potential there to push these numbers up. And in our kind of study then in South Dublin, we're kind of starting to look at where we can start bridging this gap, where we can develop these district heating systems around industrial waste heat and other heat sources as well. But I've just picked out the few that are that show good promise in terms of utilizing industrial waste heat. So we've got the Tallaght District Heating Scheme, which is the pilot project that we're currently developing. And then we've got a few other sites like Grange Castle, Clondalk and City West, which have some industrial waste heat potential, which could be further investigated. In terms of the challenges then on the district heating side, I guess as I said, there's very little tradition in district heating and cooling in Ireland, so there is a general lack of knowledge across all sectors. There's no municipality utilities, so all the utilities are delivered, by national bodies. There's no real evidence base for decision making in terms of or previously there was no evidence base in terms of heat sources and heat demand. So making decisions is very difficult, and also municipalities have a lower level of autonomy than they would in some other countries in Europe. again, the policies and regulations are all national level, not really taking into account local factors such as heat sources. And then there's also kind of current energy policy up until now didn't really consider district heating and never really had it in mind. So there was sort of some unintended barriers came out of that just through not engaging with the idea of district heating, I suppose. There's also currently no long-term planning, so energy plans tend to change with political parties, and there was no national level heat plan. But this is all starting to change now. Ireland has recently developed a climate action plan this year, and there's a number of actions in that which relate directly to district heating, and also sort of other points that indirectly point towards district heating. So the next slide then is, so this is basically a scatter plot of the barriers and kind of ranking them in terms of impact and likelihood. So I guess the one to know is that the technology is kind of the least big barrier. So I guess learning from the rest of Europe, we can see that the technology is well developed in other countries and has proven over like decades of use. And then so the kind of big ones in terms of this are customer risk. So in terms of having customers to supply heat to, and we see kind of public buildings being key in terms of this, acting as anchor loads for district heating systems. Organizational, so things like timing and kind of getting a group of stakeholders together to kind of work together and show the benefits and share information is also a huge aspect of it. And then the high upfront capital cost is obviously a large one as well. And we see kind of the municipalities playing an important role in this in terms of utilizing their low rates of borrowing. And the kind of other aspects as well as they can kind of tie up developing the district heating system with other infrastructure works. And then on the waste heat side, then kind of just presenting the opportunity for potential waste heat producers. So I guess having your waste heat connected to a district heating scheme can provide you free cooling. It can act as a heat sink for CHP, so increasing run hours or decreasing the energy used to dump heat. Potential to generate extra revenue from heat, which is currently has no value and is being, sent to drain or released into the atmosphere. There's kind of you can reduce your space requirements, so there's less need for plant on site. It's all off site. You're essentially will be replacing your heating and cooling plant with a heat exchanger. There's obviously also potential to provide heat to the site where they might need things such as preheating or low-grade process heating. And then also the potential to reduce your capacity charges for electricity and gas. So if all this equipment that was previously consuming electricity or gas to provide cooling and heating can now be provided through the district heating network, there's a reduction in the electrical and gas capacity that you require on site. So there's a monetary saving associated with that. And then the kind of challenges identified in terms of waste heat producers. So I guess the disruption to production is obviously the big one. So, but this can easily be overcome with timing and planning. So carrying out work during kind of maintenance or planned replacement periods. The kind of unease at being a guinea pig. I think providing examples of district heating and case studies. I mean, there's countless examples in Europe can help alleviate that feeling in Ireland as a country which would be very new to district heating, is so kind of increasing engagement in energy efficiency is one. So kind of being able to show the savings and addressing the potential risks. So, and then in terms of paybacks, then so kind of trust issues regarding the validity of payback periods and IRRs and all these things. So these would need to be verified either internally or independently to kind of increase that trust, really. And then like available capex. So there's often an internal kind of struggle for capex. You know, where should the money be best spent? And I think development of a strong business cases is vital to that. And then in terms of knowledge, I think there's, as it relates to the waste heat producer, it's kind of, they might not be aware of how much heat is being currently lost. And then there'll be issues around access. So again, that's kind of comes back to planning the work and developing a design that can help reduce any issues there. And then there can also be some unease from waste heat producers regarding securing supply. So that's basically having a sort of an open dialogue as regards heat supply contracts, and also kind of taking on the responsibility of operating a scheme is not something that waste heat providers would be hugely interested in general. So kind of taking that role away from them and kind of allowing the district heating company to carry out that would be very beneficial. And then just in terms of the focus of our project, really, which is the Tallaght district heating scheme in South Dublin. So this is a scheme that utilises waste heat from a data centre, this is the first time that's been done in the UK or Ireland, and it's the first large-scale not-for-profit district heating network in Ireland. So there's a lot of firsts there. So I guess through developing this project, we had to overcome a certain number of barriers, which should make future projects a lot easier. So the project itself then is basically taking the waste heat from a data center and supplying it to a new residential development, the South Dublin County Council municipality buildings, and a college, the Technical University of Tallaght. And how it operates then essentially is it takes the waste heat from the data center, passes it through a heat pump, and then we have sort of peak or backup boilers if needed, and peaking boilers, and then that heat is feeding the network and a thermal store, and then that is fed out to all the buildings connected. Then in terms of the benefits the benefits of the Tallaght district heating scheme then is obviously it utilises the waste heat that currently has no value, provides cooling to the data centre as well as providing heating to the district heating network. So it's got a very high combined efficiency. It integrates the electrical and heat grids, so it allows balancing of the grid, greater utilisation of intermittent renewables. It also has a high potential for replication due to the large number of data centres that are actually in Dublin. And then it also contributes to the local municipalities' carbon and energy efficiency targets. So it'll offset approximately 1,400 tonnes of CO2 per year, and provide, as well as providing low cost, low carbon heat to residents in the Tallaght area, and reducing the fossil fuel use by up to 99%, which obviously is a benefit in terms of security of supply and also reducing your carbon. So yeah, that's my presentation. Thanks very much for listening. And if you have any follow-up questions, you can contact me on the email address below. Okay, thank you.
Good morning, everybody. My name is Jesus Casado, and I work in the Basque Energy Agency. First of all, sorry for not being just now, as we are in Amsterdam working in another European project. So for the next minutes, I'm going to talk about the subject you can see in the screen, identification of industrial waste heat sources suitable of heat recovery, which is part of the task we are working about in the RELaTED project from EVE. As everybody knows, buildings are responsible for around 40% of total energy consumption in the European Union. And in the current situation, district heating are considered to be one of the most energy efficient heating systems in urban environments. In fact, district heating networks cover more than 13% of the total heat demand in the European Union. They are based on large combined heat power or large gas boilers. Of course, this is with a supply temperature near to 100 degrees. In the future situation, they are considered as key elements for the decarbonization of the European cities. Of course, they are expected to grow, but with some additional characteristics. There must be a synergy between nearly zero energy buildings and those buildings which are already built. They must be based on renewable or waste heat sources, and this will mean a reduction of heat losses related to a supply line temperature. And our RELaTED project, as you can see the acronym, is trying to develop all these concepts. So as you can see, it will decentralize ultra-low temperature district heating networks. Also, it will try to develop the incorporation of low-grade heat sources with minimal constraints and reduce operational costs due to fewer heat losses. This is due to the fact that supply low temperature will be used nearly to 45 degrees. In order to demonstrate all these concepts, we are developing different facilities, which are building integrated low temperature solar thermal systems. Secondly, district heating connected reversible heat pump. And finally, a triple function substation with a bidirectional heat exchange. And also, it will try to inject excess local solar heat in the grid. Here on the right, you can see a diagram. On the left, you can see the energy inputs, energy from industrial waste heat, energy from reject heat from cooling plants, and on the right you can see the buildings. Here you can see nearly zero energy buildings or positive energy houses, and here on the top you can see current buildings. All these in all these buildings will be integrated all the systems I said before. In our RELaTED project, for the different demo we will develop, the first one in Denmark, the second one in Estonia, also Serbia, and the last one will be developed in Spain, in the Basque Country. And here you can see our role in this project. We have to develop a feasibility study in order to quantify industrial waste heat in the Basque Country. To identify these waste heat sources, we have established a methodology, which first step is to identify industries which belong to intense energy consumption in our in our region. Secondly, we have developed a questionnaire in order to obtain energy figures. The objective of this question is to have a global vision of energy consumption in the industry sector. And once we have all this data, we will analyze the potential of industrial waste heat from the energy point of view, but also from the power point of view. In the first step, about identifying industries, we identify 180 companies. This was supposed to cover more than 80% of the industry energy consumption in the Basque Country. And here on the right, you can see every sector which all these companies were included. Secondly, as I said before, we prepare a questionnaire to send all these companies to obtain all these energy figures. This was an Excel file, and it included general data, energy consumption, also energy consumption depending on the use. And the main point was the description of all the facility that the company had. Furnaces, boilers, combined heat power, air compressors, and finally cooling towers, as they are considered as the main source of waste heat. On the next slide, you can see some figures of the questionnaire. For example, this one is about the energy consumption, and you can see the energy consumption of this company, which was electricity, natural gas, and diesel. This slide is related to the place where different fields were consumed. For example, this one have natural gas, which was consumed in manufacturing and also in electricity generation. And this one is related to different furnaces this company have. All of them used natural gas as a fuel. So, as a result of this collection, we obtained 124 valid questionnaires, and it covered more or less 70% of the industry energy consumption in the Basque Country, and more or less it covered 1,200 thermal furnaces, 182 boilers, 69 induction furnaces, 12 electric arc furnaces, 16 combined heat power, more than 400 air compressors, and more than 200 cooling towers. The last step of this methodology was to analyze the industrial waste heat potential. And in order to obtain all that potential, we made some calculation criteria. For example, about boilers and thermal furnace, we decided that the temperature of use will be 70 degrees. And also we consider different source quality according to working hours. For example, a source considered as A have a facility with work more than 6,000 hours per year. About induction electrical furnaces, in this case, we consider the cooling system as a source of heat. In this case, the temperature of use is 30 degrees. It could be considered as a low temperature, but as we are using heat pumps, it can be a source that can be used later in the network. Here also we consider the source quality related to working hours, About combined heat power, we have studied combustion engines and turbines. Of course, it is the not used heat in the company. And in this case, the temperature of use is next to 80 degrees. More about air compressors. In this case, the temperature of use is considered to be 80 degrees. And in cooling towers, of course, those cooling towers not considered in induction furnace, well, the temperature of use is the same, is 30 degrees. This week or last week, we've just finished or we just obtained a preliminary results, which you can see in this slide. Here in the third column, we have defined the previous temperature I have said before, and here in the second column, you can see the number of useful sources from 50 sources related to thermal furnaces to 7 sources related to induction furnaces. On the third column, we can see all that useful waste energy that could be considered in our project. And also related to this energy, you can see the average useful waste power in kilowatts. So as you can see, more or less the maximum average useful waste power is related to 2,000 kilowatts. So as a conclusion of our study, we see that there is a potential with different levels in our temperature. We have about more than 1,000 kilowatts hour with 70, 80 degrees, and 93 gigawatts hour with a temperature of 30 degrees. Next steps in our study, we will have to make a matching between all these industrial waste heat sources and energy demand. In order to develop these tasks, we will make an analysis in the vast government buildings in order to know the energy demand they have. This is in order to use them as a catalyst to promote district heating. And this is a task we will make during the next months. So as you can see, we have been working harder in order to obtain all these figures from companies, industry companies in the Basque country. We have obtained some data, and in the future we'll continue developing the tasks in order to work in the RELaTED project. So here you have my contact in order you have any doubt, and in case you want to contact me. Thank you very much.
So I think we could start by reading some questions, so maybe start the Q&A. So I've got a list of questions here. Let's start with the first one. This is direct for John O'Shea. So there is apparently a high control at national level that supposes a constraint for the penetration of district heating. Are you foreseeing to overcome this situation?
Yeah, so I guess basically, there's a lot of new policy being developed at the moment. So we'd like to include this issue for kind of debate in the new policy. So basically increasing the powers of municipalities to act as a utility. I think going back historically, I think this used to be done. And I guess it's similar to, say, a water system or whatever. So having similar powers to develop infrastructure that's for the kind of social good, similar to a water system supplying water to a community. We'd have a similar system for district heating where you're supplying heat to the community.
Thank you. Another question. So, what is an average the investment for an early adopter of waste heat producer? And what is the average time of return of the investment? It's for everyone, any panelist can respond.
Sorry, yeah, I missed the second part of the question there, sorry.
The second part is, what is the average time of return of investment?
Well, I can only speak for the scheme that I worked on, where the heat pump and the district heating network and the heat exchanger the cost of those were all borne by the council. So there was, I guess there'll be some cost of piping on the heat source side. I'm not sure what that cost would be, but I would imagine it wouldn't be significant. So I would, yeah, the paybacks would be quite short.
Yes, and this is Johan Karlsson. I can add a bit to this. So yeah, it would be very site-specific, depending on which changes you would have to do to your industrial plant, how far you would have to transfer the heat from supply to demand. Regarding the return on investment, I know about examples from 1.5 years, but it can also be much longer.
But I can add, in our particular case in Poznan, the return of investment is 10%, and the payback time is 7 years. So we are obliged to keep such indicators for the Veolia group. So 15% of IRR and 7 years payback.
Thank you. Another question. You have named cultural and historical structures as a barrier for the district heating. Could you further develop this constraint?
Yeah. Yeah, can you hear me?
Yes.
Yeah. Yeah, well, I guess cultural barriers in terms of not having a history of district heating and the kind of knowledge gap that comes out of that then. So having no culture of developing district heating, there is a significant knowledge gap in Ireland at the moment as regards, everything from legal, heat supply contracts, designing district heating networks, operating district heating networks. So yeah, all of it really.
Thank you. Another one. So South European countries need cooling systems from district heating nets. So how important is development of cooling systems, absorption systems from heat sources?
Well, there are already district cooling systems used in Southern Europe. It's not so frequent, but for example, in Barcelona, they have a district cooling system. Yeah, I think it is a good option to reduce emissions and so on. Then it should be weighed and compared to if you use cooling from heat pumps, and there the emissions would depend on how your power system is composed, so if it's clean or not.
Okay, thank you. So another question is there an appetite to give free waste heat from industry if the equipment was provided and installed at no cost by the district heating company or government? Would climate credentials for industry be enough? Any examples of this?
Well, from our point of view, there's always a need of being benefited, at least with lower heat price or some income from heat sold on the industrial customer. Of course, climate awareness and climate profits are important, but at the end of the day, the money matters. So to this time, we haven't met any customer who like to provide heat for free. Because the price for the waste heat we buy is significantly lower than the normal price. But anyway, it's not for free.
Yeah, I think in certain cases as well, the certain companies will have corporate social responsibility targets, so they'll want to be involved in a scheme that provides low carbon heat to the community. And also, I guess in some cases they'll get a benefit. They could get free cooling as a byproduct of supplying that heat. Yeah.
Thank you. So another question. As it has not been possible to hear them, what have been the major conclusions from the Basque Country case study? Can anyone answer this question?
Could you repeat, please?
Yes. So as it has not been possible to hear from the video, yes. What have been the major conclusions from the Basque Country case study?
I couldn't hear the video either, so I cannot say.
Okay. Shall we change question? So I ask another question. So lowering grid temperatures in a district heating grid seems like a discrete change in a system. For example, you cannot reduce slowly from 130 degrees to, for example, 60 degrees because all the hardware is optimized around the predefined temperature, heat exchangers, radiators, pipe diameters, etc. How is it still possible to reduce the grid temperature and what is needed to achieve it?
Yeah, I can answer. Well, in relation to Irish systems, typically the flow temperature is between 80 and 90 degrees. I guess the thing with the network is that if you reduce the flow temperature, then you'll have to reduce the return temperature because it's all sized on the delta T. So as long as this delta T is maintained, the network is effectively correctly sized. In terms of how that heat is emitted into the building, I guess typically in Ireland anyway, there's normally a factor of safety added on when sizing radiators. So you can get away with reducing the flow temperature and still providing enough heat. And also there will be, you know, as time goes by, there'll be or could potentially be upgrades to the fabric efficiency of the building. So again, a lower flow temperature would be perfectly fine in that scenario. It's kind of all about reducing the return temperature. So kind of utilizing things like thermostatic radiator valves, you know, reducing the use of bypasses on the system. All those things would help reduce the return temperature.
Thank you. How does reducing grid temperature help integration of industrial waste heat? Ideally quantified answer, please.
Well, I guess reducing the temperature, it increases the cost effectiveness of using low grade heat sources. So by reducing the temperature lift, say for example, that a heat pump would have to overcome, you can increase its efficiency, so increase its COP, and again, having a lower temperature in the network means you have a more efficient network, you know, because you've got lower heat losses. So yeah.
Yes, and another thing is that it would allow to integrate more types of different heat sources. There might be some lower temperature industrial waste heat sources that could be integrated as well.
Thank you. Another question. This is for Johan Carlson. Is taxing waste heat to incentivize its use a good idea? And how can we encourage the use of waste heat in countries where it is currently not used, when a lower national renewable heat target can be chosen if you don't plan to use waste heat?
Yes, so regarding the first question, I'm not sure if I get it completely, but I would say the other way around, that it's better not to tax it and to support the implementation of waste heat sources, for example, with subsidies. The second part of the question, I suppose it refers to the Renewable Energy Directive, Article 24, which exempts countries that have less than 2% district heating and cooling to look at the option of using more waste heat and renewables in their district heating and cooling systems. So that particular rule, or does not really encourage, of course, to use more waste heat, but that is the purpose, I suppose. So it is allowing those member states to opt out. However, this will then require that those countries meet their renewable heating and cooling targets with renewable sources instead. So it's not 1.3% that they need to meet annually, but 1.1% that they have to increase the renewable heating and cooling share instead.
Thank you. We got a new question. So how energy storage technology evolution / efficiency would affect district heating infrastructures?
Is there any specific technology? Are they referring to any specific technology?
I don't know. This is the questions. It's quite general. Maybe this one can hydrogen.
Well, maybe we can try to answer, because for our district heating, if I'm producing energy, CHP, we could have an accumulating system. It makes our production of energy more efficient. So we can produce energy at the time of less prices and accumulated heat to use it when the heat demand is most needed. From the business point of view, and from the efficiency point of view, the heat accumulation is very good for the CHP production.
Okay. So we have no more questions. I think if anyone wants to add anything, any panelist wants to add?
No.
Okay. So thank you very much for your presentations, and apologies to the participants for our technical problem and the last part of the webinar. So thank you again.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye-bye.